Okay, so I'm going to go through a load of past paper questions on powers and roots. I'm going to do it all in one go without pausing the video, so you can see if I do make any mistakes. Please do let me know in the comments, because yeah, I'm just going to go through them all in one go and explain initially in detail how we get to the answer, but then as we move further on, I'll do less explaining and just go straight to the answers as fast as I can, basically. So it should be really useful if you're doing GCSE or even A level and you just need some quick revision on powers and roots. Okay, so let's move into question one. Question one, we need to write 3 times 3 and so on as a single power of 3. So remember, when we've got 3 times 3, this is equal to 3 to the power of 2. So essentially we've got 2 3's here and we've got a power 2 there. So the amount of 3's we have is going to be the power number. So we've got 1, 2, 3, 4, 5 3's. So therefore the answer is equal to 5, not 5, is equal to 3 to the power of 5. Okay, so moving on to the second one, we need to know our addition power rule. So this is when, if we've got two powers that are being multiplied with the same base, and the base is just a number that is having the power applied to it, so the base in this case is 7, what we do is we simply add the two powers together. So this becomes 7 to the power of 5 plus 9, which is equal to, and that's over 7 to the power of 6, which is equal to 7 to the power of 14 divided by 6. The next rule that we need to know is the division rule. So we can rewrite this as 7 to the power of 14 divided by 7 to the power of 6. And for this rule, what we need to know is when we've got two bases that are the same, being divided by each other, we subtract the powers. So this is equal to 7 to the power of 14 take away 6, which is equal to 7 to the power of 8. Okay, so there's the first two questions. Let's move on to question 2a. Again, it's the addition power rule. So two bases that are the same, so we add the powers. So this is equal to 2 to the power of 3 plus 6, which is 2 to the power of 9. Moving on to the part B of question 2, we're going to rewrite this just so it's clearer. So 3 to the power of 9 divided by 3 to the power of 4. So again, the bases are the same, being divided, so we subtract the powers. So this is equal to 3 to the power of 9 take away 4, which is equal to 3 to the power of 5. Next question, it's a bit different. We need to work out the value of n. So what we need to do first of all is solve the bottom of the fraction. So this is equal to 5 to the power of n divided by, again, we're going to use the addition rule, so we add our two powers. So we have 5 to the power of 10, and this is equal to 5 to the power of 3. What we then need to do is multiply the 5 to the power of 10 by both sides, so that we are left with 5 to the power of n on its own. So when we do multiply both sides of the equation by 5 to the power of 10, we are left with 5 to the power n is equal to 5 to the power of 3 multiplied by 5 to the power of 10. And again, we are going to use our addition rule. I'm going to stop highlighting it soon because it should become fairly obvious when we need to use it. So therefore we can say that 5 to the power of n is equal to 5 to the power of 13. And just comparing these two expressions, we can see that the n is being replaced by 13, so therefore n is equal to 13. Okay, next question. Again, really easy one, just the addition power rule. So 2 to the power of 3 plus 4 equals 2 to the power of 7. Next question. Okay, it's a bit different. So we've got two regular numbers without any powers associated, and they are equal to a third regular number, and there's 1 2 to the power of n. So what we're going to do is solve this first of all. So we've got 280 is equal to 2 to the power of n multiplied by 35. We're then going to divide both sides by 35, so we get 280 divided by 35 is equal to 2 to the power of n. Just grab my calculator. So 280 divided by 35 is equal to 8. So 8 is equal to 2n. And just from looking at this, I can see that n is going to be 3 as 2 cubed is 3. But if you're unsure, we can do 2 times 2 equals 4. 2 times 2 times 2 equals 8. So therefore 2 to the power of n equals 8, n equals 3. Okay, Next question, simple one again, just the addition power rule. So it's 7 to the power of 5 plus 3, which is equal to 7 to the power of 8. So we just do 5 plus 3, so equal to 7 to the power of 8. Again, another easy one, 5 to the power of 9, take away 3. So this is equal to 5 to the power of 6. So for part B we need to solve this expression here. So again, this one's slightly more difficult than some of the previous ones, but the first thing to do is we need to move this 2n on the bottom of our fraction over to the other side, and to do that we're going to multiply both sides of the expression by 2n, or 2 to the power n, sorry. So we've got 2 to the power of 9 multiplied by 2 to the power of 4 is equal to 2 to the 8 multiplied by 2 to the n. Okay, next thing to do is to use our addition rule. So we just add these two powers to get 2 to the power of 13. It's now equal to 2 to the power 8, and then we've got multiplied by 2 to the power of n. Next thing to do is to divide both sides by 2 to the power of 8, so that we have our 2 to the power of n on its own. So when we do that we have 2 to the 13. Then I'm going to do this in one step. So when we divide by a power, we take away the two indices using the power division rule. So 13, then we've got take away 8, and this is equal to 2 to the power of n. So we have 2 to the power of 5 equals 2 to the n, and therefore just from comparing two sides of the expression we can see that 5 must be equal to n. So we just write that down. Right, moving on to question 5a part 1. We need to simplify our answers in index form. So again, it's just the addition rule, but there's three terms we need to apply it to here. So we get 6 to the power of 5 plus 2 plus 1. So always remember that even though there's no power on this 6, that is just a 1. It's 6 to the power of 1. So this is equal to 6 to the power of 5 plus 2 plus 1, which is 8. Moving on to part 2. This time we've got 9 to the power of 7, but the entire expression is squared, so we can rewrite this to make it a bit clearer as 9 to the 7 multiplied by itself, which is 9 to the power of 7. That's all the squared means. So again, all we have to go back to now is our addition rule, where we just add the two powers. So this is equal to 9 to the power of 14. A quick way to get to this answer is we can notice that all we have to do is multiply the 7 by the 2. Okay, next question. Similar to a few of the ones that we've had before, first thing to do, we need to get the 5 to the power 6 over to the other side. So that leaves us with 5 to the n multiplied by 5 to the 3. It's now equal to 5 to the 4 multiplied by 5 to the 6. We then use our addition rule on the right hand side. So we have 5 to the n multiplied by 5 to the 3. It's now equal to 5 to the power of 10. We then divide both sides by 5 to the power of 3 to leave our 5 to the n on its own on the left hand side. So this is now equal to 5 to the power of 10, take away 3. So 5 to the power of n is equal to 5 to the power of 7, so n is therefore equal to 7. Okay, hopefully these are getting easier as we go through them. It's just the same things over and over again, but it's just about getting into your head and getting some practice with actually doing these questions. That's the most important thing in maths, is definitely practice, so you can apply your knowledge to exam questions which you haven't seen before. So again, another easy one. All we have to do is add the powers, so we get 2 to the power of 7. Again, another easy one. We have to subtract the powers, so we get 3 to the power of 6. This one's a bit different, so we need to work out what x is, and this is just a rule that you have to know. So anything, so let's just say we've got x to the power of 0, that is always going to equal 1. So no matter what value we have for x, it could be 1, it could be 100, it could be a million, anything to the power 0 is always equal to 1. Okay, so this is just a rule that you need to know. So therefore x is equal to 0, as 5 to the power of 0 will equal 1 due to this rule here. Okay, so that is just one thing that you just need to learn. Next question, we need to evaluate the following, giving our answers as fractions. So now we're introducing negative powers, and all this means is when we've got a negative power, we can keep the base the same, so the base 2 stays the same, and we have to do 1 over our base, okay? And then whatever power we had here, minus 3, we take away the negative sign, and we just put the 3 on the 2 in the bottom. So when we solve this, The 1 of course stays the same, and we've got 2 times 2 times 2, which is equal to 1 over 8. Okay, so when we've got a negative power, we write down our fraction 1 over the base, then we take away the negative sign, and we just write down the power 3. Okay, next question, we've got a fractional power. So what to the power 1/3 means, so if we've got a half, this is equal to square root, 1/3 is equal to the cube root, and so on. So this expression we can rewrite to get the cube root of 27 over 343, and we can then break this down a bit further. So we can then say this is equal to the cube root of 27 divided by the cube root of 343, and then we just simply have to solve the cube root of 27 and 343. So when we do solve that, we can say, okay, this equals, then the cube root of 27 is 3, and the cube root of 343, I'm not too sure what it is, let me just quickly get my calculator. 343, 7. Okay, so the cube root of 343 is 7, so the answer is 3 over 7. Next question, we've got the square root of 3 over 8, and then it's all to the power 4. So for this question, we need to rewrite it first of all. So our 3/8 is the base essentially, and that stays the same. But then we can rewrite the square root in this form. We can say the square root is the same as doing a half, because remember up here, where a half is equal to the square root when the half is the power up here, we can simply rewrite our square root as 3/8 to the power of a half. What we've then got is this entire thing is being raised to the power of 4. I'm just going to move this down a bit so that doesn't overlap with the previous question. Okay. So I'm going to move it off. Right, there we go. So remember from, where's it gone? From this question here, where we've got a power raised to a power, we simply multiply the two together. So what we have to do in this question is we have to multiply off 4 by half. So when we do that, we get 3/8, our base stays the same, and then it's all being raised now to the power of 4 times 1/2, which is equal to 2. So it's just 3/8 squared, and 3/8 squared is equal to 3 squared over 8 squared, which is equal to 9 over 64. Okay, so that one's a bit more difficult, but simple steps that we just need to follow, and the actual maths itself isn't too difficult. It's just knowing what steps to do and in what order. Okay, next question. We need to find the value of 9 to the power of a half, or raised to the power of 4. So again, same rule, we just have to multiply the two indices. Just do that a bit clearer. Yep, so multiply the two indices. So this becomes 9 to the power of a half times by 4, which is 2, so 9 squared, which is equal to 81. Okay, we now need to express 5 to the power of 20 as a power of 25. Okay, so this question's actually quite difficult. You might not know how to start it, but the way we do this is we can see that 5 squared is equal to 25. So how can we use this and apply it to this question? Well, we can therefore say that 25 is equal to 5 squared, as we've stated here. So what we can then say is 5 is equal to the square root of 25, okay? So another way of writing this is 5 is equal to 25 to the power of 1/2. Let me just move this out of the way as we've run out of room. Okay, so what we can do with this is we can then rewrite this expression here as 25 to the power of a half, and then all raised to the power of 20. And again, we just have to use the same rule that we've been applying previously, where we just multiply our two powers, and this leaves us with 25 to the power of 10. Part C, we need to express root 8 as a power of 2. So it's similar to this question. We need to convert one number into the form of another and express as a power, basically. So root 8 is a power of 2. What we can say first of all is that 8 is equal to 2 cubed. We need to notice this, and therefore we can say that the square root of 8 is therefore going to be equal to 2 cubed, but then we've got the square root applied, so we can just say the square root of 2 cubed. Okay. Next thing to do is to rewrite our square root as a half, so we can then say this is equal to 2 to the power of 3, and then all raised to the power of a half. So we just replaced our square root with the half outside the brackets. Okay, next thing is to just multiply our two powers. So when we do that, we get 2 to the power of 3 multiplied by a half, which is 3 over 2. And that's the final answer. We've expressed root 8 as a power of 2. Next question, we need to simplify this expression here. So again, same rule, we just need to multiply our two powers together. But there's a key thing to notice here. In all the other expressions, there hasn't been a number in front of a part of algebra. So when there's actually a number in front of our base, the base being h in this case, we have to also cube the number 4. So what this becomes is 4 cubed multiplied by h to the power of 2 over 3, and this entire thing is being cubed. Okay, so what we've got is 4 cubed, which is 64, multiplied by h, and we just multiplied these two powers, to the power of 2/3 multiplied by 3, so we get 6 over 3, which is h squared. And then we can just simplify by removing the multiply sign to get 64h squared. Okay, next question, we need to work out the value of k, where k is up here. Right, so the first thing to do is simplify the top and the bottom of the fraction. So the top, we can say a to the power of root a. This is equal to a multiplied by a to the power of a half, and then we just simply add our two powers together. So imagine this is a 1, and we just add them, so we get a to the power of 3 over 2. For the bottom of the fraction, what we've got is the cube root of a squared, so cube root of a squared, which is equal to a squared all to the power of 1/3, and then we simply multiply our two exponents, so multiply them, and we get a to the power of 2 over 3. Right, what we then need to do is form our fraction from the initial question up here, but in the forms that we've created down here. So we've now got a to the power of 3 over 2 divided by a to the power of 2/3. So I'm going to rewrite this, so a to the 3 over 2 divided by a to the power of 2 over 3, and then we just have to subtract our two powers. But the issue here is we don't have a common denominator, so we need to get one. So we're going to multiply the fraction here by 2, not by 2, by 3, and this one by 2. So I'll just use a different colour. So we multiply by 3, multiply by 2. So this is now equal to a to the power of 9 over 6, and then take away our 4 over 6. So the 9 over 6 comes from here, and the 4 over 6 comes from here, okay? And we just have to subtract them as they are being divided. And this is therefore equal to a to the power of 9, take away 4 over 6, which is 5 over 6, okay? Next question, we need to express 8 to the power of 1/2 as a power of 2. So similar to a couple of the previous questions now. The first thing to say is that 2 cubed is equal to 8. So therefore, we can say that 8 to the power of 1/2 is equal to 2 cubed all to the power of 1/2. And then we just have to multiply our two powers together. So we end up with 2 to the power of 3 over 2. Another similar example here, we need to recognise that 3 squared is equal to 9. So we can say the cube root of 3 is equal to Let me see. Okay, so we need to do one more line actually before we say that. So we can therefore also say that 3 is equal to the square root of 9. So we can say that the square root of 3 is equal to the square root of 9, and then the entire thing is having the square root applied to it. And all we have to do here is write both square roots as a half. So our first one is that one, so we'll write 9 to the power of 1 half, and then the square root on the outside is being applied to the entire expression, so we have a half outside the bracket as well. When we have this, all we have to do is multiply the two powers and we get 9 to the power of 1/4. Okay, question C, we need to express 1 over 4 root 2 as a power of 2. So this question's kind of difficult. What we need to spot is that 1/4 is equal to 2 to the power of negative 2. Because if we think about this, let's quickly solve this. 2 to the power of negative 2, we write 1 over 2 squared, which is equal to 1 over 4. Okay, so 1/4 is equal to 2 to the power of negative 2. So what we've then got is we have got 2 to the power of negative 2, and we've also got on the bottom of our fraction we've got root 2. So this is equal to 2 to the power of negative 2 over 2 to the power of 1 half, and we can then rewrite this to make it a bit easier for ourselves as 2 to the power of negative 2 divided by 2 to the power of 1 half, and then all we have to do is subtract the powers. So this becomes 2 to the power of negative 2 take away 1 half, which is equal to 2 to the power of negative 2 take away half is negative 5 over 2. So that question's a bit more difficult. You've got to make the connection that 1/4 is equal to 2 to the power of negative 2. Kind of difficult to spot, but again, it's all with practice. The more you do this kind of stuff, the easier you will spot these little things, these little details. So yeah, practice, practice and practice. That's all you have to do. Right, write down the value of 10 to the power 0. Remember, anything to the power 0 is equal to 1. So therefore, 10 to the power 0 is no different, it's equal to 1. Write down the value of 10 to the power of negative 2. So again, when we've got a negative power, we keep the base the same. We do 1 over it, and we remove the negative sign from the power, and just put the actual number down. So 1 over 10 squared is equal to 1 over 100. Right, 8 is a power of 2, so that's simple. 2 cubed is equal to 8. We then need to write 2 as a power of 8. So if we take the cube root of both sides in this expression, what we get is that 2 is equal to the cube root of 8. So we'll just tidy up. 2 is equal to 8 to the power of 1/3. Yes, that's right, and 2 is a power of 8, yeah. Okay. We then need to write 1/4 as a power of 2. So remember, in this question here, we spotted how to do that. So 1/4 is equal to 1 over 2 squared, which is equal to 2 to the power of negative 2. Okay, next question, we need to evaluate this expression here. So, okay, the first thing to do is to realise the 3 is a cube root and the 2 is a squared. So what we do is you write down our expression. So we've got the cube root of 27 over 343, and the entire thing is being squared. Okay, so let's solve inside the brackets first. So the cube root of 27, in fact, you know what, we'll just rewrite this to make it a bit easier. So we've got the cube root of 27 all over the cube root of 343, then the entire thing is being squared. So this is equal to, we've got 3 on the top divided by, I think it was 7, wasn't it? The cube root of 343. Let's just check. Yeah, it was 7. So divided by 7, and then the entire thing is being squared. So this is equal to 3 squared over 7 squared. So we get 9 over 49. Okay. Next question. I believe this is the final one. No, okay, just quite a few more. So question 12, we need to solve 3 multiplied by 4 to the power of 2k plus 8 equals 24. So let's just rewrite this to make it a bit clearer. 3 multiplied by 4 to the power of 2k plus 8 equals 24. First thing to do is divide both sides by 3. So when we do that, we get 4 to the power of 2k plus 8 is now equal to 3. No, it's not equal to 3. It's equal to 8, as, well, 8 times 3 is 24, of course. Okay, next thing to do is we need to realise that 4 and 8 can both be written as a power of 2. Now, again, this is kind of difficult to spot, but we can see that 2 squared is, of course, equal to 4, and 2 cubed is equal to 8. So, what we have to do is we need to convert the 4 and the 8 in terms of 2. So this becomes 2 cubed, the left hand side, 2 cubed, and then the entire thing is being raised by 2 to the power of k. Not 2 to the power of k, it's being raised to the power of 2k plus 8. So what we've done is we've replaced this 4 by 2 squared, and then the 4 had 2k plus 8 being raised to it, and we've done the exact same here. Okay, so we need to make this equal to our right hand side, which is just 2 cubed. What we can then do is we can compare the two sides. Actually, the first thing is we need to solve this, so we need to multiply our powers. So multiply, and we get 2 to the power of 2 brackets 2k plus 8 equals 2 to the power of 3. So expanding the bracket, we get 2 to the power of 4k plus 16 is equal to 2 to the power of 3. So now as the base is the same in both, and they are equal to each other, this means that 4k plus 16 must be equal to 3. So 4k plus 16 must now be equal to 3. So just solve the equation as you normally would. Take away 16 from both sides, get minus 13. So therefore k is equal to minus 13 over 4. That is probably the most difficult question you're going to get at GCSE level for indices. A difficult question, but when you know how to do it, it's straightforward. But it's just spotting that the 4 here and the 8 are both capable of being written as 2 to the power of something, 2 to the power of 2 and 2 to the power of 3. But hopefully you can see how to do that kind of a question now. So next question, 13. We are told y equals 16 multiplied by 10 to the power of 8k, where k is an integer. Okay, and we need to find an expression in terms of k for y to the power of 5 over 4. And we need to give our answer in standard form. Okay, so this is the first time I'm seeing this question, so I need to get my head around it as well. So we're told this, great. K is an integer, great. Find an expression in terms of k for y to the power of 5 over 4. Interesting. Okay. Let's see. How can we do this? I'm pretty stumped here. Let's have a think. So we need to find an expression in terms of k for y is equal to 5 to the power of 5 over 4. Right. Okay. Let's see, what can we do here? I guess what we can do is we can just say we're going to apply this to both sides of the equation. So we get y to the power of 5 over 4 is equal to 16 to the power of 5 over 4 multiplied by 10 to the power of 8k to the power of 5 over 4. I'm not sure if this is right at all, but we'll go over it and see if we actually get anywhere. I'm going to redo that 5, it's terrible. 5 over 4, there we go. Right, so now let's solve this. So we have y 5 over 4 equals, just grab my calculator, so 16 to the power of 5 over 4 is equal to 32. So we've now got 32. multiplied by, we just use our power rule here, so the base stays the same of course, 10 to the power of 8k multiplied by 5 over 4, so y to the power of 5 over 4 is equal to 32 times 10 to the power of 40k over 4, which is 10k. And yeah, that's the answer we've got. I don't actually have the answer sheet for this, but at the end of the video I'll go over it and say if it's right or not. Hopefully it is. Yeah, so that's the way I'd go about it. So what we've done is we've said, right, okay, they want to replace y with y to the power of 5 over 4, which we've done. We then need to obviously apply this to every term in the expression, which we've done again. And yeah, that's how we've gone about it, and we've given our expression in terms of k for y to the power of 5 over 4. So pretty sure that's right. I mean, we've just used our instinct here, I guess, because it's a very strange question. But yeah, I'll go over this at the end of the video, which is going to be pretty soon. Just as and if it's not, I'll correct it. Anyway, question 14a, last two questions. Yep. So we're told that we've got the square root of a all to the power of 7 equals ka, where k is equal to a to the n, right? Find the value of n. Okay, let's rewrite this. So we've got the square root of a all to the 7 equals k square root of a. Again, I'm not really sure where this is going, but we're just going to solve as you normally would. So we'll change the root a into a to the power of a half all to the power of 7, and that's equal to k to the power, not to the power, ka to the power of 1/2. Right, we'll solve the left hand side to get a to the power of 7 over 2, simply by multiplying, is equal to k a to the half. We'll then divide both sides by a to the half, so we then get a to the 7 over 2, and then take away the half, is equal to k. So therefore a to the power of 7 over 2 take away a half, which is 6 over 2, which is 3, is now equal to k. And yeah, they wanted k equals a to the power of n. We need to find the value of n, so the final thing to say is that n is equal to 3. Okay, quite a difficult question again, but yeah, just use your instinct. Use the first thing I do for any question that I'm not really sure where it's going, such as this, is to just solve what I can. So I knew that we could solve this. I knew that we could rearrange to bring this a over and leave k on its own, and then it was the right way to do it in the end. Yeah, so there you go. Right, part B, express 1 over 2 root 2 as a power of 2. Right, so again we need to spot something here. We need to turn the half into a power of 2, and we can do this by saying that 2 to the power of negative 1 is equal to 1 over 2. So that's something to spot. 2 to the power of negative 1 is equal to a half. So we can then rewrite our 1 over 2 root 2. This is now equal to, we've got 2 to the power of negative 1 all over root 2. Okay, and this is equal to 2 to the power of negative 1 divided by 2 to the half. And we can rewrite this as 2 to the power of negative 1 divided by 2 to the half. So all we have to do is subtract the powers. So this is now equal to 2 to the power of negative 1, take away 1/2, which equals 2 to the power of negative 3 over 2. Okay, right, they are all the questions done. Some are pretty difficult, a lot were easy. But I'm going to find the mark scheme and just check if I've actually got this question right, because I'm not too sure. Not this question, hold on, where is it? This, yeah, this question here. Not sure if it's right, so I'm going to check now, bear with me. Right, okay, I found the mark scheme finally, and this would get you all the marks apart from one. So the key thing which I've missed out is give your answer in standard form, and standard form, we can't have 32, we need to convert that to a 3.2. So the final line of working that we have to do is write y to the power of 5 over 4 is equal to 3.2 times by 10 to the power of 10k, and as we've divided this by 10, to get back to our final answer we need to multiply by 10, and to do so, as we are already multiplying by 10, all we have to do is add a 1 here, so to the power of 10k plus 1, and that accounts for the change in decimal place here. So the plus 1 there accounts for the division of 10 that we did here. So yeah, we got the right kind of working out the right answer almost, but we just forgot to leave our answer in standard form. And that's a good point, because I've done this before myself. It's really important to go back over the exam paper and just check, how do they want the answer given? Do they want it as a fraction, a decimal, in standard form, 2 significant figures, 3, so on? You know, it's easy marks, which I've lost that one before. And you know, 5 minutes checking your paper at the end, you can easily pick these up.